Well, welcome back to a new video. In this video, I am going to be talking about a few topics related to C++. Now, instead of me going through an IDE and writing the code and showing you the execution and what's the output of that, running those codes, I would rather go ahead here and use the Paint software in Microsoft Windows to explain those concepts because I'll be honest, they're not that easy. And I remember when I was a student, it gives me a lot of headache because back at the time, I tried to explain it to myself and I couldn't understand it very, very well until one day, I don't know how, all of a sudden it became very, very clear to me and it became very easy for me to understand. And most importantly, this topic is extremely important, the one that I'm going to be covering right now. So I hope with the demo that I'm going to be going through, it would just make your job easier to understand the concept. So let me just go straight to the point. We are going to be talking about pointers and references and arrays and seeing the relationship between all of these concepts. Now those three concepts or four concepts that I just mentioned, they are related to how data are organized inside the main memory. And for that reason, I want you to imagine that the memory is simply what you're seeing in this area here. So this is your main memory inside your computer system, the place where the data is going to be stored before it's going to be processed by the CPU. Now, just to understand this, you have to understand that a main memory in a computer system contains memory locations. And this is just a group of them, by the way. It's not the whole entire thing. We have billions of them inside a computer system. But I'm just showing you, imagine this is a group of memory locations. Now, what you need to know about memory location, every single memory location has something called the memory address. And every single memory address is a unique number. Now, those numbers that you see here presents those memory addresses. But you have to understand those are just numbers that I came up with. In reality, the number is way too long than that. What I'm trying to do here is just to give you an idea to imagine. So you'll be able to imagine what's inside your memory, how your what does your memory look like, stuff like that. So, I want you to imagine, I want you to look here, and this is a fact actually. Every single memory location has a relationship with the memory location next to it when it comes to the address. And you can see here, this is 12ACB01. Then one next to it is 12ACB02, and then 3, and then 4, and 4. So you can see there's like a sequence. Those are the addresses of these memory locations. Now, with that being said, you should know that, again, we have a main memory. Inside the main memory, we have memory locations, and everything you're running your program is simply going to be stored inside the memory location before it's processed by the CPU. Every single memory location is known by its memory location address, and those memory location addresses are simply in a sequence form. Okay? Now, with that being said, let's just go straight to what we know already. And what we know already that when I type integer x equal 100, you're creating a variable and you're calling that variable x, and x will hold the value of 100. But in reality, what's going on? You're simply issuing an order to the operating system, and that order for the operating system is simply going to go to the memory and is going to try to look for an empty space or a space, not empty space, let me be specific, a space that's not utilized by any other programs. Let's imagine this is the space. And it's going to simply call it x, and it's going to store the value 100 inside it. Let me try to make it look a little bit cooler. Okay, so here we go. This is x, and this is what's inside x. Now, in your program, every time you want to use x for any reason, you refer to the memory location with x. But what you don't know that behind the scenes, x simply is just created for you. So you would know how do you call this memory location. But in reality, everything that's going to be done and processed for this memory location is going to be done using the address itself. So when you say, for example, show me x, in reality, what's going on behind the scene, the thing that you don't see, is simply you're calling the memory location address to show me what's the value inside it. Now, the whole point of this is simply to make your job easier as a programmer. And instead of you memorizing all these numbers and processing them and understand where they are and how do you have access to them, we're taking all of that out of your shoulder, and we're simply telling you it's called X. So you call X. Same thing if I do with Y. Another memory location is going to be chosen. Now, not necessarily the one that I'm showing you here, but just because I'm limited with the space, I'm going to be choosing this one. This is going to be called Y, and this is going to hold the value of 200. And that's what we know so far. Now, with that being said, let's move on and talk about something called references. References is, and let me just define it now, and then I'm going to try to explain it to you. References in C++ simply will allow you to have two identifiers to reference the same memory location. I'm pretty sure you might not understand a word from what I just said. But that's the reason why I have this graph here, so I can make your job a lot easier. Let's go back to the first example. So X is referencing this memory location. Y is referencing this memory location. So let's look at those two codes. We have the original, we have the reference. Now I want you to pay attention. This by itself is the reference, not the ampersand. But this is how we create a reference. So before I show you and talk about the syntax, let's look here and say, for example, we're going to use this space here, and we're going to call it original. So I'm going to go short, ORI. Okay? And we're going to hold the value of 100 here. Let's look at the line that we have here. And I want you to imagine, and just imagine, that this ampersand doesn't exist here. It doesn't exist here. Okay? I don't want to, I can delete it. Let me just take it out. I hope I can undo it later, but let me just imagine if I took this out. Okay? Now, the execution of this line simply will do the following. It will take and use another space, and it's going to call it reference, and it's going to take whatever the value of original, which is 10, and it's going to store it here. Now remember here, this is in case that ampersand wasn't there. But let me show you the effect of that ampersand. I'm going to undo everything I just did here, and I'll put it back. So this ampersand simply is telling me that reference here, REF, is actually a reference. And it should reference the same memory location that the original is referencing. So what does that simply mean? That simply implies that original and reference are simply going to be referencing the same spot inside the memory. So 10. Original is referencing the same spot in the memory. Reference is referencing the same spot inside the memory. Now, what is the point of this? I'll tell you what is the point of this. Have you seen those videos in TikTok and all these social media? Tell me that you're rich without telling me you are rich. Okay? So let me put it here. Change original without changing original. Okay? So what is that supposed to mean? I'll tell you something. Let's imagine I want to change original, ORI, to 100. But I don't want to use ORI, original. For any reason, I may not have access to it directly. So, if I want to change original directly, all I have to do is just come here and say original equal 100. And that's it. I'm done. I changed it. But again, and this is something happens in C++ a lot, I want to change original to 100. But at a certain point in the program, this is not available for me. I cannot have access to it. I'm at a certain spot in my program where I don't have access to original. Well, if that's the case, here's what you can do. I can come here and say ref equal 100. And that line by itself simply will change the value from 10 to 100, and that again is going to be reflected directly on the original. Let me just, it's too long to write it here. I'll just keep it ORI. So this is what reference is. Reference will allow you to have two identifiers, in this case original and reference, to be referencing the same memory location. And that simply implies if you manipulate one of those identifiers, by default the other one will get affected by it. And this is what I'm showing you. I was able here to change reference to 100. And again, if I come here and say cout original, it will simply print the 100. And that's what is a reference. Now, again, I'll tell you something, and I can guarantee you, you might actually being asked yourself, so what's the point? Like, why would I want to do that? Well, this is a class that's going to last for 4 months. Whenever we get to a point where this is going to be and something that we are going to have to use, I'll remind you about this. But at this point, since we are just having a review about C++, I'm just showing you how things are done. Okay? Now, there is another way to, I would not say another way. There's another technique we have in C++, another feature we have in C++. It's called pointers. Pointers somehow, in some certain situations, will give you the same benefits that you will get from references. But pointers are a little bit more complicated comparing to reference, so let's put it that way. And also, pointers gives you more control. And for that reason, C++, until this day, it's a live programming language because you as a programmer have great control over your memory, over the data stored inside the memory. So it is a really, really big deal. So let's go ahead and talk about pointers and how do they work. And in this case, I am just going to show you those 3 lines of code. And then after that, I will show you some applications. But let's start with this. I'm creating a variable called value, and I'm storing the value 10 in it. So let's just imagine the operating system chose this one here, store the value 10 in it, and it's called value. Very straightforward, very easy, very simple. Now, I want you to pay attention to the memory location address. Okay? Let's go to the next line. Now, in the next line, and I want you to distinguish between those 2 lines. This ampersand used here is different than when it's used here. I'm creating a variable called PTR. But have you noticed that there's an asterisk before the PTR? That simply implies that PTR is a pointer. Okay? Now you may ask me, what is a pointer? Well, a pointer is, and let me give you the definition and then I'll show you what it is. A pointer is a variable that can only store an address of another memory location. I wish I could say it in a little bit easier way. Pointer is a variable that can store an address of another memory location. So you may ask me, okay, so what is that supposed to mean? Okay, let's just imagine that here, this is PTR. Okay, so this is PTR. Now, PTR can only hold, and I want you to pay attention to this, an address. So it can hold any of these values that you see here. You see them? All these values, any one of them could be stored here. But you, as a programmer, the operating system will not allow you to do that manually. Like you cannot come to the PTR and store 12ACD20, for example. You cannot type the address itself. But here's what you can do. Very, very important. You can go to a variable that you have, which is value here, ask for the address of value. So here's value. This is 10. The value stored inside, and here's the address of that memory location. So it's 12ACB08. So by the time this line here is executed, simply I'm going to hold the value of 12ACB08. So simply this address here is stored here because of this line here. So I'm storing the address of the variable value inside this PTR. Now, at this point, you also have the right to ask the same question. What is the point of that? Why would I want to do that? Just like how I said, if I want to change original without actually changing original, now I'm going to ask you, can I change value without actually changing value? And the answer will be yes. And you can do that as following. If you come here and say asterisk PTR equal 100, you're simply asking your computer to go to PTR, use the address of PTR, which is 12ACB08, go to that memory location, which is this one, and change whatever value is there to 100. And that's what this line simply is doing. So if you think about it, both of those two techniques that I just explained will simply give you access to a variable and be able to change it without actually going and change it manually. Let me get back to the point. Why would I want to do that? Well, there will be a lot of applications where you need to do that. One of them, as I said, sometimes a variable that you need to change may not be accessible. So how do I change it? Well, you have two choices. You have using a reference, you can use a pointer. Now, Java programming language realized the similarity when it comes to the functionality of those two terms, and Java decided to get rid of the pointers and rely totally on references. C++ decided to have them both, and to be honest, this is not the only application that we use pointers for. There's a lot more applications for that, but this is, again, not a C++ programming language, so I don't want to give you a headache about that, but let me just give you an idea because this is something we're going to be using in the future a lot. Pointers are 35% of what this class is all about. So it's extremely important to understand what are pointers. At this point, I'm not going to get into the details, but you must have an idea and you must know. A pointer is a variable that we are going to use to store the address of another variable. Doing it that way is simply will give you indirect access to that variable, and we'll see how can I use this term indirect access to another variable and how is that going to work. So I hope this made it a little bit easier to understand. And again, if I just go and talk the talk without showing you the memories and how does it work, it's going to be a little bit difficult to understand the concept. Now, with that being said, is this the only thing that I need to know about pointers? No, actually, we have more about pointers. And let me just show you this example. And probably, I'm not sure if we're going to need this or not, but it's good to know. Here's what I'm doing here. Look at this difference between this pointer and this pointer. This pointer, I directly referenced a space inside the memory, as you can see here. So value, and I took the address of value, assigned it to this one. But what's going on here in this one? Well, here's what's going to happen. What's going to happen here is that you're simply going to create a pointer. Let's go with p and and this p and will hold a value, but what is that value? Well, simply it's a memory location. But what memory location? You don't know, I don't know, nobody knows. The only one who knows is the operating system itself. So let's say the operating system randomly chose this value here. Not randomly, of course, it has to be free. Nobody's using it. So simply what's going to be stored here is 12, A, C, B, 0, and 15. So that's the value that's stored here. Now, the question is, what do we have here? Well, at this point, it's just, let's say, an empty space. Or actually, there's a random value there, but we call it garbage. Again, because it doesn't represent anything. So here's what I can do. I can come here and say asterisk p num equal, let's say 500. Pay attention how I use the asterisk when I have access to the value itself. So simply what's going to happen, 500 is going to be stored here. Okay? So if you think about, if you compare this one to this one, we have two pointers. Each one of them is holding a value. An address. That address simply represents another memory location. It just happened in this case that the address is for the variable value, and it happened in this case it's just a memory location that I don't know, you don't know, just the operating system only know, and we assign the value 500 to that address. Now you may ask, so I see the application here that you're trying to change value without having access to value. So what's the point of this? Well, we use this technique when we have limitations of memory. Simply means, let's imagine this is the whole memory that I have. Like this is, those memory locations that you see in this picture are the only memory that I have. So I create a variable, I store the value of 500 in it, and now I need to create a new variable, and simply there is no space for a new variable. Okay? Because I use them all. Think about the watch, the smartwatch you have, the Apple Watch that you have. Again, it's very, very limited with the amount of memory that's available for it. So what do I do if I need more memory? Well, here's what you do. With those pointers, it's called the dynamic allocated memories. In the middle of your program, you can actually erase them so you can make a space for new variables later on. In general, when you create a variable in a program, that variable is going to be alive as long as your program is alive. When your program is terminated, the memory space is going to be freed for other applications. But here, when you actually use pointers using this technique that I'm pointing at here, you have the freedom in the middle of the program before it's terminated to come here and type delete, del, p, and m. And simply what's going to happen, this is going to be erased, this is going to be erased, those two memory locations are going to be available so you can use them in another program. And for another variable in your program. Now this is again a very, very simple explanation for pointers and references. In the future, when we're going to be talking about trees, lists, mostly tree and lists and graphs maybe, we are going to talk about pointers a lot, and I'm going to remind you about this. But at this point, it's very, very important to have an idea about what is a pointer and what is a reference. Now, with that being said, I've actually been doing my preparing for this lecture. Look at the magic that's going to happen now. Voila. I'm using the same example here, but it's a different story here. What do we have here? Well, let me just delete those. We have an array. So what is an array? Well, here's an array. Array, if you look at it, what's the difference between this array or how do we create variables in general? It's this part here. I'm creating an array called numbers, and numbers simply are going to have three values. So imagine this is numbers. And simply because I said 3, that simply means there will be 3 spaces reserved. Oh, my skills they stink. Let's just try again. Here we go. Much better. So those 3 spaces are reserved for numbers. Now here's what I want you to pay attention. The value of numbers by itself, like if I come here and say cout numbers, is simply whatever the address is. So this here is actually what's stored inside numbers. But I want you to think about numbers as a reference. I don't want to see a reference. Yeah, a reference for those 3 values that you see here. Okay? Now, with that being said, let me erase what I just did here. I'm trying to keep it as clean as possible. Now you may ask a question, so what is this? Well, this one here is an identical way to get the same effect as this one. And it's simply using a pointer. Let's just put it that way. And you can get whatever you want to get done using this technique or this technique is going to be exactly the same. In reality, we stick with this technique here much more than this one because this one will imply using some extra steps. But I'm just telling you this just in case you see it somewhere. So what am I having here? I'm having, again, a pointer this time. It's called P array. And I'm reserving 3 spaces for it. This one and this one and this one. And again, if I want to print array itself, P array, it's simply going to show me this value here. That's the address. Now, of course, if you go and run it by yourself, you're not going to see the exact same value. It's going to show you a value that relies and depends on the memory that you have in your computer system. Okay, so with that being said, this is actually exactly what we have in those 2 lines. It's simply going to show me this one here, and for this one, it's going to show me this one here. What do we have here? Well, what I'm trying to do here, I'm trying to assign values to numbers and to P arrays. So let's go here with this one. It's a single regular for loop that's going to go for 3 times. Look how we have access to the numbers. We put this is called indexes. And indexes will hold the value of 0, 1, and 2. Just like how in Java. Okay? And I'm trying to change the value of it to 10. So simply, by the time this line is executed 3 times, I will have 10 here, 10 here, and 10 here. Let's look at the 2 lines underneath it. Now those 2 lines will give me the same effect of this one for the P array. So first of all, you put an asterisk, which is you're dereferencing the address itself, and you're assigning, I'm going to put 20. So this line here by itself, it will assign the value 20 here. But I had to have this extra line here so I can move to the next one, which is this one. So what am I doing here? I'm adding 1 to P array. Now, originally P array held a value of 12ACB05. When you add 1 to it, it's going to be 6. So when I come back, I'm simply going to be referencing this memory location. So 20 is going to be assigned here, and then 20 is going to be assigned here, and I'm done after that. Okay, so this is how we get the job done. Now, the other example that you see here, it's simply me repeating the same thing, only this time I'm using the indexes for the P array, and for the second one I'm using numbers, asterisks for the second one. So the output of those simply will come here and change this one to 200, 200, 200, and this will change it to 100 and 100 and 100. This is pretty much everything you need to know about this chapter. Next chapter, we're going to talk about classes and objects and maybe inheritance, because those are the most important topics when we need to know, we need to have an idea. It's going to be very simple, very straightforward. Again, I am going to keep saying this so you would not get afraid of this. This is not a programming class. Programming is part of it, but I'm not going to judge you based on your programming skills. You need to know a little bit. You passed a Java class before, so this should not be a complicated topic for you. You know how to create classes, objects. You know how to create variables. You know how to do for loops, stuff like that. The only thing that I would say is different here is pointers. And pointers are important. I hope this explanation give you an idea. And let me just go back here. And I'm going to emphasize and I'm going to tell you that this part here is the most important part here. Because later we're going to realize that we have a problem with the memory. And the only way for us to get out of that problem is simply to use pointers. So it's important to understand what is a pointer. A pointer, again, it's a variable that will hold an address of another variable. And that's pretty much it. And then we will take that definition and see how can I create chains. Okay? Chains of values. Like one value will lead me to the other, will lead me to the other, will lead me to the other. And you will see that it's going to generate something very, very beautiful. Okay? I am happy that this video is not as long as the first one. I'm just going to post it now, give it to you guys. You will have a whole week to go through it. And now remember something very, very important. If you need any help at any time, please come and see me. Thank you for watching. I'll see you guys later.